So let me give you a little background on this. This is just some things pulled out of a book that's coming out. And I've been working on collective action, transnational, typically transnational, for about 45 years at this point. And so at first it seemed like I couldn't see any commonality. And then eventually, after about 30 years, I guess I'm a slow learner, it all started to gel. And I started to see basic principles that could be taken from the study of environment, transported to the study of terrorism, transported to the study of eradication of diseases, and all these other problems that we face in terms of humankind. As I've written, since there's so many years, the globe has acquired more and more billions of people, which have made these problems a lot worse. And that's going to continue into your lifetime. And yeah, I do have slides to show you, but I'm going to first stay away from the slides and then go into the slides. If you look at transnational cooperation, is it all failures? And one would have to say, no, it's not. We have a global standard of weights and measures. We've eradicated infectious diseases. Some we've been very successful on, and some we have not. Scott Barrett, who's in the audience, has done some really interesting papers on that, and just the differences between smallpox versus polio. It's fascinating. And we've developed antibiotics. We're going to have to be real good at developing antibiotics for the new superbugs that we're facing right now. We've been able to make great strides in terms of the ozone layer, which protects us. We've done a very poor job at this point in terms of climate change. And I want to talk about that. That's one of the major things I want to talk about. And I also want to talk about a regional problem, which is acid rain. And I want to talk about that in terms of sulfur acid rain versus nitrogen acid rain. And it turns out that although both of them have very similar processes, we've made tremendous strides with respect to sulfur acid rain, and we've made much less strides with respect to nitrogen acid rain. So what I'm doing is, I'm not basically a case study person, but for this type of audience, I'm going to look at a couple different case studies. And by looking at these case studies, you can draw out some of the real interesting differences that allow you to tip over and be able to solve a problem versus not solve a problem, which is what we want to know. Transnational cooperation takes many forms. We have certainly treaties, and this particular conference is a lot about treaties. We've got bilateral understandings. We've got multilateral institutions that assist, and we have regulatory bodies as well. And some of these regulatory bodies are global. So there's many different ways that has occurred. Why is transnational cooperation so important these days? Well, I would argue there's a number of reasons. One, population and the expansion of population. Two, nations have continued to break apart. And what might be a problem for one nation, when it breaks apart, is now a transnational problem between two nations. And so we've actually are acquiring more transnational problems. Technology. You know, technology is kind of a two-edged sword. Some parts of technology really helps us with transnational cooperations. Some really hurts us with transnational cooperation. One of the reasons why we're so aware of the problems is that we now have so much ability to look down at this planet and see things that we had no idea was occurring before. And we also have the ability to be in the planet and look up and see things that we did not know that was occurring before. And also the whole notion of globalization, which is just a greater exchange between countries of the world, and regionalization, which is a greater exchange in the regional side. One wants to know, when are these problems self-ameliorating and when are they not? Because if a problem is able to fix itself, then why put all of the resources together to fix it? Why not save those resources and go after the problems that are not self-correcting? And so that's a very important insight. Now, what facilitates transnational cooperation? And some of this came out in some of the talks today. So one thing that facilitates is if the consequences of not doing anything is really dire. Okay. Now, you would like to know that sooner than later, and you would like that to be a case where you can do something once you've recognized that it's a dire problem. Typically, once the uncertainty is resolved. So for instance, with the ozone depletion, once the scientists really realized that the chlorofluorocarbons was causing the depletion of the ozone layer as well as other bromide and other substances, then there was a call to action. And there was some, as you'll see, there was some very special circumstances that made that call to action very effective. The payoffs and the temporal nature of the payoffs. Are the payoffs immediate or are they way into the future? If the payoffs are way into the future, that's not a good thing. Because as altruistic as generations are, they don't seem to be as altruistic as the planet might need. And I always think back in terms of altruism and generations, you come to England, a great country with some of the greatest cathedrals in the world, and you think about the sacrifice that one generation made to another. Sometimes these cathedrals took hundreds of years, 200, 300, 400 years to get built, yet one generation gave it off to another, and the other was committed to that. If there was even a part of that, we wouldn't be here worried about climate change. If there was that kind of altruism and commitment. So that's something that one has to think about. What makes for intergenerational collective action and what doesn't make for intergenerational collective action. Agreements and cooperation is a lot easier when the countries are asked to sacrifice very little. So if the agreements are very loose in the sense that countries don't have to give up a lot of autonomy, those agreements are much easier to achieve. If there's a leader nation, and if that leader nation is part of that problem that you want to solve, they've got to be a main participant of the problem. I remember once being in the UN and listening to the discussion about climate change in Fiji saying, we're a leader nation in this. But unfortunately, as well-intended as Fiji is, Fiji isn't the part of the problem, right? If a leader nation like the United States, a leader nation like Japan, like Russia, would be much more important than Fiji leading that particular effort. And also if the behavior is observable. So those are the key ingredients. So I'd like to start off a lecture by trying to say, what are the key ingredients that we should look at? Other possible facilitators would be the number of parties, selective incentives, things that help participants in a selective way so that they buy into it in an important way, and properly designed institutions. So there's a whole parallel aspect of collective action, which is how do you design institutions? How should you try to have cost sharing? If there is cost sharing, how should that be comprised? Should it be comprised based on income? Should it be comprised based on what each country is getting? And if you look at the international organizations out there, they're comprised in many, many different ways. And IMF is so much different than World Bank, and it's so much different than Interpol. And each one of those are quite different. Why some of these work better than others very much has to do with the way those institutions are designed. So that's a really, really important thing. Now, I'm going to use just some semi-technical concepts, but they're not very technical. One's the notion of a public good. So a public good doesn't have to be publicly provided. Public good is a good that its benefits are non-excludable. Once it's provided, everybody gets it. So you have a free rider incentive there. Why pay for something you're going to get no matter what? 2, it's non-rival. My consumption doesn't take away from what you get. So if I were to clean up the air over the British Isles, anybody going out there and taking a big fresh breath of air isn't going to crowd anybody else or make that experience any less pleasing. And there's a third property. And this property, when I was listening to the talks today, this property might have been mentioned once, but it changes everything. And that's the property of the aggregation technology. How does individual contributions determine what's out there to consume? The typical way of thinking of it is in terms of summation, that what I give and you give, we add it together and that's what's out there. But there can also be the notion of weakest link. And weakest link means that whoever gives the least determines what's there for everybody. And so for instance, if you're trying to keep a contagious disease from spreading, whichever country that gets infected is the least adequate in keeping that disease from spreading is going to determine how much at risk we all are. So in a situation like that, weakest link is really important. Another one is best shot. Whoever gives the most determines what the amount is. So when I was listening to some of the talks today, and almost always the underlying assumption was summation. And in my mind as a theorist, I put weakest link in there and I could turn the proposition right in its head. So it really does make a difference. And it also makes a difference in when cooperation works and when cooperation doesn't work. So I'm going to do some paired comparisons. At the global level, I'm going to compare climate change with ozone depletion. And Scott's done work on that as well. You've had early papers on that. I think I looked at it in the early 90s at one point to look at this comparison. Although our work is very parallel, some of it is quite different as well. So sometimes there's a different emphasis on what works and what doesn't. But I assume they have in depth to you. So, and the second one is this nitrogen and sulfur acid rain. And I could look at other problems as well. I mean, I could go into terrorism and look at one form of terrorism versus another. And often the collective action problem is totally 180 degrees different from one another, which countries unfortunately do not understand. Countries really like the template theory, that once they've solved one problem, that problem is a template for solving anything else that seems to have those words in it. And that doesn't really work. So like, for instance, in terrorism, what you would do to go after a group which is offensive is so much different than what you would do in terms of protecting against a group. And the results of your actions are, again, like 180 degrees different from each other. And that's very important because most countries that have transnational terrorism, either in their own soil or elsewhere directed against them, have to face both of those problems. And often solving one problem is just the opposite from solving the other problem. So dealing with multiple problems at a time makes it very interesting sometimes. Okay, so now let me give you one insight. The insight that's usually used, if you look at political science, and even if you look at economics and related disciplines, is if they understand the notion of the public good, they'll say, give me two problems, and if they have the same qualities on those three dimensions I talked about, let's say they were completely non-rival, they were completely non-excludable, and they were summation, and their spillover range, the range of who they affect, is exactly the same, then the collective action solution is exactly the same. That's the notion you get from the literature, and that's absolutely the notion you get from the theoretical literature. What I'm going to show you today is I'm going to take two problems, one at the global level, one at the regional level, and on those those three dimensions, they are exactly the same, those two problems. Yet the outcomes are absolutely different, which says you've got to think beyond the standard notions. If any of you are students of Mansur Olson's excellent work about collective action, he comes up with a bunch of propositions about group size and group composition. And a lot of people will just say, okay, you get problems with the same group size, same group composition, then they're going to operate the same. And it turns out, again, that's just a first cut at it. And unfortunately, that doesn't really get you all the way there. So you've got to be a little bit more. Okay, so the ozone depletion problem. And let's see, let me, because I know you're all wondering about whether I actually prepared this or not. So, okay, Okay, so ozone depletion. So we're protected by an ozone layer. And this ozone layer is between 10 and 25 miles up there. And if you collapse the whole thing together, it's 3 millimeters thick. That's when it was at its thickest, 3 millimeters thick. And because of the ozone layer, it protects us against certain types of skin cancers, it protects us against cataracts, it protects a lot of species, it does a lot of help to us, even though we can't see it, but life on this planet is what it is because it's got this ozone layer. It doesn't mean life wouldn't exist in this planet, it just means it would be different to some extent. And at first, it was thought, well, nothing's going to really destroy this ozone layer. And there was some speculation that CFCs, chlorofluorocarbons, was doing something about the ozone layers. But the chlorofluorocarbons were actually engineered in such a way as to be a very, very stable substance. So the belief was that it would never break apart and cause any kind of chemical reactions up in the upper atmosphere or what have you. And we learned later, by some scientists who were given a Nobel Prize for this, that under very, very cold conditions, the chlorine in the chlorofluorocarbons gets separated and can combine with the ozone in the stratosphere, form a new substance, and in that way, the ozone is captured and basically destroyed from the layer. And it wasn't until the British Antarctica survey evidence in 1985, we showed this 40% decline. And again, let me go back to Scott's work. You got, I don't know if it's a footnote or in your paper, in the actual book itself, where you talk about the satellites that were already up there, and that the satellites would have discovered that. However, the satellites were set up like a Dolby system, so that if a reading got outside of the range that NASA thought it should be in, it kicked it back into the range. Who would ever send out a monitoring device that would not be able to tell you the truth? I always thought that was great. So that's a little bit of the physics. Let me continue without going to a slide yet, because as soon as I go to the slide, well, the eyes go up and I want to get away from that. So why did we make so much progress with that, with doing something about that? Actually, within a short period of time after we formed the treaty, we actually banned CFCs, and they went to zero. I mean, why did we do that as a planet? That's an amazing thing. And in fact, as we found out there were more and more substances, we included more and more substances on that particular list. And why was that? Well, I think one of the original things was this EPA study in 1987, which basically showed that the cost to the United States in terms of skin cancers and cataracts and other harmful effects, forget about other countries, just to the United States, when compared to the cost of getting rid of the CFCs, was a benefit-cost ratio of 1,000 to 1. Now that's a no-brainer. You know, today a lot of the talks I heard were about prisoner's dilemma, where the benefit is less than the cost to the individual. Here was a case where the benefit was greater than the cost. And in fact, even though the other big producers and consumers didn't do a comparable study, they looked at that particular study and they said, well, we've got to be somewhere in the same range. So they realized that it was in their private interest to do something. Now, CFCs were kind of different as well. They had a fairly limited number of uses. Cleansing, refrigeration was a really big use. But they had a limited number of uses. It wasn't like climate change and greenhouse gases, where as we're sitting in this room, we're all producing greenhouse gases. I mean, there's like nothing you can do that won't produce some kind of carbon footprint. In fact, there were a lot of countries that had almost no use of CFCs at the time that the treaty was formed. But the important countries thought that there was a net benefit, even if they couldn't get everyone else to agree. So it was kind of a unique situation. And so if we go ahead and so I don't know how well you can read that, but these are all of the protocols. So we first had the convention, which basically said, like all UN things, it says, you better look at this problem. And let's come back later if there's a concern, and let's make a protocol which commits ratifiers to doing something. And that's the Montreal Protocol. And the number of ratifiers, because I believe EU qualifies as one ratifier, it's basically universal agreement now. The Beijing, maybe since the time I put this slide together, may now be universal agreement. But this is amazing in terms of cooperation. And what you also see over in here is that more and more substances were being added. And here's the one interesting one. When they phased out the CFCs, the substitute was hydrochlorofluorocarbon, which still has chlorine in it, so it much less. So it still had a degradation to the ozone layer. But then they developed the HFCs, hydrofluorocarbons, which had no chlorine in it whatsoever. And at that point, they phased out even the HCFCs. So quite interesting. Now, why did they do that? Well, for one thing, this was mentioned today, the companies who made these substances were also the ones who made the substitutes. So they were going to make billions by the substitute. And they really liked that the treaties also gave a little bit of a grace period where they could still sell, so they could utilize up their stockpile so that they wouldn't lose any money, they wouldn't have to flush anything away or somehow or another make a chemical reaction and uncombine it. So it was just a win-win position. So there was no lobbying on their part with respect to Congress or other parliamentary bodies. It was also very concentrated. I think it was about a quarter produced in the US. There was just a few countries that produced it. And there was, I think, 16 firms worldwide that produced them. So again, you had very concentrated. This is not the carbon problem, where all of us are producing carbon. So that made for a difference. And so here's some of the background. Just 3 nations, U.S., Japan, and the former Soviet Union, this is at the time of the signing, accounted for 46% of CFC emissions. Just 12 countries caused 78% of the emissions. Plus, unlike climate change, nobody gains from ozone depletion. No way do you gain from ozone depletion. The companies would be the only gainers, but they were gaining by not using the depleters because they were producing the others. It's not like climate change where maybe Canada might be a much more hospitable environment and might have a much greater growing season. So countries didn't necessarily want to take a wait and see attitude with respect to that. And then you had the leadership. The leadership was the U.S., which was really, really important because the U.S. was one of the most important problems. Now, I said earlier that temporal aspects are important. Here's a problem that can be reversed within a 35 to 60 year period. And if you start to look at the situation, you wanted to try to help the countries that didn't have the wherewithal to make a switchover if they needed to at a later stage. And the multilateral fund could do that. And the multilateral fund, yeah, there were millions of dollars involved, but shoring up the weakest links, those that couldn't do it on their own, was fairly costless compared to shoring up the weakest links in a global or in a climate change problem. Much different levels of expenditure involved in that. The media focused on the benefits, not the cost, which was just opposite with respect to the global warming problem or the climate change problem. This over in here just shows what's happening. These are atmospheric concentration. I only go up to here because I want to show what's happening as those treaties or those protocols got formulated and written. You can see that on all of the key measures, we're going down. So not only did they sign, they were abiding by it. But they had a substitute, and so it was pretty easy to abide by it. Okay, so climate change. So we switched to climate change. And we can do this one perhaps a little faster. So climate change comes from a greenhouse effect. And it's not just the Earth's atmosphere getting warmer, but there's lots of things that happen. And some countries become warmer, some countries become colder, and some ocean currents change. And from Texas, we must have had one of the coldest winters ever. I mean, and Texas is not a cold place, yet other states had one of the warmest winters ever. So it's not evenly distributed. The greenhouse gases include carbon dioxide, methane, CFCs, HCFCs, HFCs as well. So, one problem does affect the other problem, and nitrous oxides. And there's a lot of human activity that leads to this particular problem. It's not just burning of fossil fuels, but it's also deforestation. There's a number of things that lead to this problem, and there's a number of main contributors. And there's all kinds of predictions about the rise in sea level, the rise in temperature, and at this point, some of those predictions have actually been under what was initially thought about 20 years ago. So it seems to be something that we should be concerned about. So the consequences are dire. At least a lot of people would agree that it's dire. And yet, even though the Montreal Protocol, which is actually at least at this moment, called for an average 5% decline. Over that period from 1980 on, there was a 50% increase. So we haven't really made a lot of progress. We're at a point now that the US is officially not part of the protocol. Russia, once they've seen that now the protocol is going to bite, in other words, they're going to have to cut back, they pulled out. Canada pulled out. Australia says, well, you know, we're a small continent country, so we should have different conditions than others. And so you've got a lot of very important countries with large carbon footprints trying to get exceptions out of this. You got India and China. They make an equity argument. Well, we weren't the cause of the problem in the first place, which is absolutely true. But at the same time, they are now going to be very much important in terms of the process. So when I wrote Global Challenges I guess I wrote it in 1996, but it came out in 1997. The one thing that critics said about that book that I got wrong was I said that climate change was the hardest of all the collective action problems that we faced, and that it would be the most difficult to solve. And the critics just said, he doesn't know what he's talking about. Now, fast forward to now, and I don't think I was far off that mark, that it is a really hard problem to solve, and for a number of reasons. Okay, so I think I've done all of that. So climate change. We've got Kyoto Protocol, framed on the 11th December 1997, entered into force February 2005. I mean, look at just the years it took for it to enter into force. The failure to date, the main GHG emitters, I've listed them, no longer party to the protocol. Now there's going to be a new commitment period, and one doesn't know what that's going to involve. So I've just, as my comparison, I've put them side by side. And what you see is that most of them are just opposite. Emissions concentrated in relatively few countries for ozone shield. Virtually every country adding to GHGs for the climate change. 2, every country loses from a thinning ozone layer. In terms of climate change, there may very well be gainers and losers, and none of that is known with certainty. Commercial gains from substitutes for the ozone problem. For the climate change problem, initially, people didn't see the commercial gains. I think that's changing. That there can be gains from alternative sources of energy, although there needs to be a lot of study of that and development. The ozone layer, the uncertainty was resolved, and we knew the processes and the consequences, and there's still unresolved issues or with respect to the processes and consequences of global warming. And I can go on, you know, leadership in one, lack of leadership in the other, at least among the countries that really matter. I understand the EU is a leader, that's great, and that's important. But there's other really important countries that don't even want to sign the climate change. And so these two things are, these two comparisons are why there's differences. So what I'll do next is just turn to the acid rain. Now the acid rain problem, I should say about the publicness on the climate change and the ozone depletion. Global, pure public good, non-rival, non-excludable summation technology, they're both exactly the same. So that doesn't get you anywhere in terms of understanding the problem. Now let's go to the acid rain problem. Very different kind of public good problem. A little bit like the water paper that you did. So on the acid rain problem, there is a certain degree of non-excludability, but it's perfectly rivaled. When you put the sulfur and the nitrogen up into the air, and a ton falls in one country, that same ton can't fall in any other countries. So there's a type of rivalry there for both problems. What's the technology of aggregation? Technology is a weighted sum, which means that you put weights on which country emits, and those weights are computed based on real collected data, and those weights have to do with wind direction, primarily with wind direction, but not totally, because when lows sit over Europe, the wind direction changes. And so, but it has been figured out. It's been figured out for each year, and if you do a statistical study of the transport matrix, which I'll say a little more about in a minute, that transport matrix from year to year is unchanged from a statistical point of view. So, so that's kind of important. But the publicness part is exactly the same in the two. Now the control strategies. You know, well, first let's go into where the sources are. So the sources of sulfur is primarily power plants, and then it's industry, residential and commercial, second to the last bullet point. Nitrogen is primarily cars and trucks. So you've got the individual player being much more important in the nitrogen problem, and you've got government-controlled monopolies in most countries being the problem in terms of the sulfur. That makes a difference in terms of control. Now, our control strategies, for both, the control strategies are pretty much the same. Improved efficiency is probably the best control strategy for both of them. For sulfur, low sulfur coals. For NOx, low NOx burners and power plants, emission standards controls, catalytic converters on cars. So what are some differences that make these two problems diverge in terms of being able to be solved? One thing is nitrogen emissions are lighter than sulfur emissions, which means that nitrogen emissions fall further away from the source. And in many cases, a fairly large percentage actually fall outside of the treaty areas, which makes for a difference as well, if they fall at sea. Sulfur falls much closer to home. Now there's other differences. Sulfur, because it is heavier, tends to fall on the country itself. Now that's not true in the United Kingdom. It's not true in the United Kingdom because the United Kingdom built and engineered very high smokestacks. In fact, I was friends with the person who worked as the economist on determining the height of the smokestacks in the 70s. And they were determined in such a way that the particles would fall on Scotland, which seemed to be justice, or to Scandinavia. Now, if you look at who's signed the Helsinki Protocol on sulfur, I'll tell you one country that didn't sign it, the UK. Okay? Whereas the UK has been very good in lots of environmental treaties because it wasn't falling on soil here. So you can start to see, this subtlety in terms of collective action and countries being very interested in what's in it for them. Okay, so here, let me do this, working on two different machines. Okay, and I know this looks very complicated. It's not very complicated. This is called a transport matrix. And this is a unifying way of looking at all the technologies of aggregation. So that A11 says what percentage of country one's emission falls on country one. That's what it says. The diagonal is what percentage of your garbage falls on you. That's a very strong motivating force, right? Very strong motivating force. If I look above the diagonal and I number my countries from west to east, and since the basic airflow is from west to east, then what is going to happen is most of the weight of the matrix is above the diagonal, which means that a lot of the percentages from the emitter countries, which are in the columns, versus the recipients, which are in the rows, is going to be in the upper portion. Now, we're at the time that Helsinki and those things were signed, where were the communist countries at that point? They were in that top portion. The communist countries at that time, they typically did not sign environmental treaties. But as soon as the EMEP showed them what these transport matrices looked like, and that they were importing everybody else's garbage, it was like, where do we sign? So, you know, communists are really good capitalists. So that was very interesting at that point. See, that's what happens when you resolve the uncertainty and people really know who's getting what from whom. Now, I say that this is a way of looking at all of the aggregation technologies. It's also a way of looking at virtually every type of public good. Because if I had zeros everywhere in the matrix and I had ones along the diagonal, I have a private good. I have a good where what you produce is what you consume, all of it. Nobody, if you're diligent, nobody else gets any of it. You got a piece of cake and you're really diligent, nobody gets any of the crumbs. And if you put a bag over it, nobody gets any of the smell. So that's the private good situation. The public good situation, pure public good situation, is ones everywhere. Everywhere. Perfectly non-rival, perfectly non-excludable. And then the weighted sum allows us for all the in-between technologies. And we can put weakest link in here, we could put best shot in here. And now, when you add up this column over here, this is one's the emitter, and you add it up over the recipients. If all of the recipients are in the treaty area, then the treaty's going to be okay. But if the recipients, if there's countries not here or places where the pollutants can fall that's not there, then you've got reasons for some not doing anything. And it turns out for sulfur, it's pretty much added up to ones, to the number of countries. Pretty much. Because remember, these are percentages. So if you put 1 million tons up, only 1 million tons can fall. We've normalized by the total, so they should add up to 1 if everything is in that particular region. That's the only technical part of the lecture. So, okay, so let me show you a picture. Right here is a picture. See the top line? That's all self-pollution and sulfur. The broken line is self-pollution and nitrogen. It's about half. About half. That meant that countries had much more reason to do something just because of what they were doing to themselves. Forget about others in a situation like that. Also notice, the bigger the country, the more self-pollution. So the Soviet Union had tremendous self-pollution, and the reason why that is because it's so large. So you have a situation where I guess the graph must be cut off, and so the Soviets are out over here somewhere, but they go up to like 100%. So So you can see that that's a big difference between the two problems. Okay. Okay, so let's just go back. Okay, so there's your treaties. You've got the Long-Range Transboundary Air Pollution Convention, again a convention. Then you've got the Helsinki Protocol, which was sulfur. You've got the Sofia Protocol, which was NOx. You got the Oslo Protocol. In fact, Michael's got a great paper on that, and talking about how cost was used. That was one of the first treaties where we actually tried to find out marginal costs and equated. You know, all that economics out there to think that these treaties, one from another, never really worried about marginal costs is amazing. The volatile organic compounds, they came in at a later stage, and then more recently your other substances, your NOx, ammonia, fine particulates. Now, why did these substances come in later on? Why weren't they right off the start? And the reason why was when they started to compute the transport matrices, they had the technology at first to do the sulfur. It was a little harder to keep track of the nitrogen. It was very, very hard to keep track of the VOCs, and there were so many of them. So we didn't have the uncertainty resolved until down the road. Once that uncertainty was resolved, then countries were more willing to come on. The other thing I would say, and this is, I guess, my skepticism or my cynicism is probably the better word, is that when you look at the sulfur, at the time that the treaty was formulated, the countries had already cut back. And they were very close to the limits they put on. And every time they got better than those limits, they formed an updated protocol that raised those limits so that the protocols were always catching up to what they've actually done. The NOx, they hadn't done much at all. And so when the protocol was formulated for that, it didn't really demand very much. So for the Sofia, it's the third one down, reduction in NOx to 1987 levels by 3 December. So there was no cutback, not like the sulfur, which was 30%. And in fact, here's a table where here's the treaty countries, 20.59% in 1985. Where was this? Reduction in sulfur from 1980 to 1985. They had already achieved 21%. The treaty wouldn't go into effect for a number of years. So they just kind of fast forwarded, said, well, where would we be at the time the treaty goes into effect? It was like at 30% on average, so they made it 30%. So you could say, okay, is that really transnational cooperation? And that's a matter of how you look at it. In a way, it isn't, but in a way it is, because what it did was then force the laggards to do something, or else for the ones that had the technologies to help out these laggards. And it set up a framework. When you look at the nitrogen at the time that the treaty was formulated, they hadn't quite gone back to the 0% of 1987, but they were very close. So again, what was achieved was what was encoded into the treaty itself. Okay, so my last comparison is this comparison here, where again, I have a typo on the one side. It should be there rather than 3. There was a lot of self-pollution in sulfur, much less in nitrogen. The travel distances were different. Most of the sulfur fell within the treaty area. NOx, much more fell outside of the treaty area. The polluters were easy to control, public utilities and large corporations in terms of sulfur. It was much harder to control vehicles and truck owners. And you'll see, even to this day, that nitrogen does really badly. It's going to do really badly over the next few years. It does really badly when we're not in recession. Because at that point, there's much more use of vehicles, there's much more commerce, so there's much more trucks and cars on the road. The information on the transport matrix was known much sooner for the sulfur than for the NOx, and the levels that were achieved at the time of the treaties were much different. Okay, so that's the main things. Let me say something about some policy recommendation, at least with respect to sulfur and with respect to nitrogen. One thing that struck me about sulfur and nitrogen was, I think, and I know there's people in this audience who've said otherwise, I think it was really smart that they didn't bundle the problems. Even though we know from bargaining theory, a lot of times when you bundle problems, you're able to kind of bargain over those problems. I think here it would have been a weakest link kind of thing. And that whichever problem was the hardest to get a handle on, which was the VOCs, that would have held back all of the others. Whereas this way, countries move forward on the sulfur, then they move forward on the nitrogen, and they move forward on each one separately. The second thing, I think I mentioned this earlier, I don't think there's any one template to be used, not only for sulfur and nitrogen, for any of these problems. I think it's very important to treat each of these problems somewhat differently and to look to see what the subtleties are. The great importance of getting rid of uncertainty, all of these problems where we have made progress is after we've gotten rid of these uncertainties. And I also think it's very useful to start these treaties very, very loose and tighten them over time, which is what we've been seeing with respect to at least the Ozone Treaty. Had they said at first, let's phase CFCs out totally, and that was the first Montreal Protocol, that might have taken years and years to get signed rather than go into effect so quickly. And I think it's also important to realize that collective action is very multi-layered. So for instance, in the nitrogen sulfur problem, the notion that vehicle owners is where the collective action must come. The countries can sign whatever they want, but if the individuals who they depend on to carry it out cannot be controlled, then that's a problem. So with the power plants, they could be controlled. They were mostly licensed monopolies. Okay, so my last slide. Let me say something probably not on the slide. So where do we go from here? And certainly, I think we've learned a lot about collective action over the last so many years. We've learned a lot about how game theory informs us about collective action. And game theory, and I'm a big believer of game theory, but I also think that game theory is not the total end of knowing about this stuff. That it's really, really important to also empirically look at it and to see to what extent these games actually tell us something. And when you use game theory empirically, it's very, very difficult because every problem is endogenous because it all depends on what somebody else is doing. So their actions cannot be treated as being exogenous, which lots of models try to treat them as exogenous. So you've got to use the methods of dealing with endogeneity right from the start, which makes the problems very, very difficult to deal with, but not intractable. And I also like the notion that one can learn from one set of problems, like on any of the security problems, the terrorism problems. And you can learn a lot from them, and then you can take that learning and put it over to the environment, and vice versa. For instance, a big notion in the environment is the notion of a transferable externality. What that means is you don't want something to land on your surface, let's say, and so you do something to shift it away. And that's like the smokestacks in the UK. Okay? None of us want a terrorist attack on our soil. So we protect greatly, defend greatly. Why? Because we prefer, even if it's our people being murdered, we prefer it to happen in another country's soil than on our own soil. It's very embarrassing when it happens on our own soil. That's a transferable externality. So every principle learned in the environmental studies about transferable externality applies in this particular security situation as well. So there's a lot of learning that one can do from both. What I didn't talk about this time, which I have been studying and is really fascinating, is the dynamics as well, and how these problems are solved dynamically, and the differential games and the dynamics. And I didn't go to every session because there were parallel sessions and I couldn't will myself into 3 places at the same time. I'm working on that, but I didn't manage to do that. So I don't know, I don't want to shortchange anybody, but I didn't really hear anything dynamic today, and that's a big thing in terms of environment. Okay, so I do game theory. I don't think a game that's played with 2 stages is a dynamic game, okay? So I think that's something that people really need to look at. So I'll stop there.